Rather than scatter the earth with jagged lightning bolts, the shrouds of dense clouds powering the storm spit 150 miles upward, far enough to graze the ionosphere, or the edge of space. This violent, backward burst of electricity would soon be classified as one of nature's most mysterious atmospheric phenomena, a gigantic jet. Gigantic jets are simply luminous beams born alongside regular lightning bolts, yet pointed in the opposite direction. But they're a lot stronger than their downward-facing counterparts, sometimes even threatening space vehicles or other technologies floating in our planet's orbit. And this particular one was incredibly intense. It's considered the most powerful of its kind studied so far, carrying an estimated 300 coulombs of electrical charge, a whopping 100 times more than typical lightning bolts hold. Over the past 2 decades, scientists have identified several of these strange forces, but many of those sightings were accidental catches from the public. For instance, a violet streak was imaged from an airplane passing over Bhadrak, India, and another was spotted with a nighttime camera near the 6,240-foot summit of Shikonkong Mountain in China. In 2013, NASA added an experiment to the ISS in order to help get a better, more actively placed look at the scene above cloud tops so we can catch gigantic jets in action. Still, the science community doesn't have many observing systems tailored to the search. Which is why Oklahoma's 2018 incident was serendipitous. By happenstance, this extreme event occurred close to a bunch of relevant science instruments in the state, like satellite networks and a lightning mapping system that detects what are called very high-frequency signals. A citizen scientist in the area even photographed it with a low-light camera. So, drawing on all of these clues, a crew of scientists collected as much data as possible about the jet to try to paint a detailed retelling of what happened 4 years ago in the swirling Oklahoman sky. We were able to map this gigantic jet in 3 dimensions with really high-quality data. Levi Boggs, a research scientist at the Georgia Tech Research Institute and an author of a paper on the structure published August 3 in the journal Science Advances, said in a press release. Such a 3-dimensional structure is important in the quest to decode gigantic jets because their ascension from clouds means they're often obscured from view. We were able to see very high-frequency sources above the cloud top, which had not been seen before with this level of detail, Boggs said. And those VHF signals offered a goldmine of information about gigantic jets. Basically, lightning bolts emanating from thunderstorm clouds are produced by a combination of leaders and streamers. Leaders are the result of electrical charge differences that help develop lightning, and streamers are found at the very tip of those developing bolts. Together, these forces work to propagate electricity channeled from within the stormy cloud, but leaders typically forms the bulk of discharge. The new study's researchers first of all definitively saw the gigantic jet-producing leaders and streamers were situated above the thunderstorm cloud during Oklahoma's event, rather than toward the bottom where they'd normally be found. Second of all, the radio and optical data show the first clear evidence that the VHF observed by lightning networks is produced by streamers ahead of the leader, the study authors wrote.